welcome to the Tejano Virtual Events Happy Math Hour, your weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it at a later time, and also for those who may have missed today's presentation may be able to watch it at a more convenient time. Thank you. So now at this time, please mute your mics for the best sound experience. We don't want the feedback interfering with today's important lesson. Today is the last Happy Math Hour of the spring semester. We will see you in the summer. Without further ado, here is Mr. Ruben Carrizales.
Good morning, everyone. And again, thank you for joining us for our last Friday Happy Math Hour. I hope you all had a good semester. It's gone quick and it's almost over. So let's go ahead and prepare for our final exam. So again, for those of you who are here for the Math 1324, you're going to find a link to the 1324 under your chat. So we'll go ahead and for those of you who are here for 1324, go ahead and click on that link. The rest of you, let's go ahead and get started with the review for our Math 1314. So let's go ahead and start with this problem. It says, find any intercepts and test for symmetry with respect to both axis and the origin. So we have this equation, y is equal to minus 2x plus 1. And we'll go ahead and find our x-intercepts and y-intercepts. So again, just to remember and to refresh, to find our x-intercepts, we're going to set or let y equal 0, and then we're going to solve for x. So replace the y with the 0 and do a little bit of algebra, and we find out that x is equal to 1/2. Okay? So once we have our x, again, this is, we can put it as an ordered pair. This is like a computer question, a homework question. So the ordered pair that we're going to put for our x-intercept, here the x was 1/2, and we set our y equal to 0. So inversely, to find our y-intercept, we're going to now set x equal to 0, and then we're going to solve for y. So when we do that, we'll replace x for 0. We go ahead and simplify and solve for y, and we find that y is equal to 1. And again, here they're asking us to put it as an ordered pair. So we have 0, 1. Now we didn't have to put these parentheses here because the computer already put them on there. So don't put double parentheses on your homework, or if you're in an online class, don't put parentheses. Since the computer is already putting the parentheses, you don't have to put them in. The computer will mark it wrong if you do the double. Okay, so don't do that. So now let's check for the symmetry. So there's several cases that we can go over to test for symmetry, but the best way to see this one is if we graph it. We know that this is a line, and this line has no particular symmetry in respect to our x-y axis or origin. Okay. So just to review, to check for symmetry for the x-axis symmetry, what we do is we replace the y value with a negative y, and if we get the same equation, then it has that symmetry. So again, when we do this for our equation y is equal to minus 2x plus 1, and we replace the y with a negative y, we have this minus y is equal to minus 2x plus y, and then we want to solve for y again. And we do that by dividing by a negative 1 or multiplying by negative 1 on both sides. And we see that we get y is equal to 2x minus 1, which is not the same equation. So since it's not the same equation, it does not have x-axis symmetry. For the y-axis symmetry, we replace the x with a negative x, and then we solve again. So this is our equation, y is equal to minus 2x plus 1. Again, we replace the x with a negative x, and we simplify, and we have our equation y is equal to 2x plus 1. This one is also not the exact same equation that we started with. So since it altered it, it does not have y-axis symmetry. And then to check for the origin symmetry, we replace both the x and the y with a negative, and we solve for y again. And when we do this, we see that we still get a different equation. It's not the same one that we started with. The equation that was given has a +1, this has a -1. So again, since it didn't produce the same exact equation when we changed the signs for our prospective variables, it has no symmetry. Okay. All right, let's look at another example. So this is an example of a circle, and it says write the standard form of equation of the circle with the given characteristics. And the characteristics that they're asking us to get is a circle that has a center at -4, 2, and it has a radius of 2. Okay, so we know that the standard form of a circle is given by this: x minus h squared plus y minus k squared is equal to r squared. Again, where our h and k is our center and r refers to our radius. So they're giving us what we need in order to get the equation. Here they said that the center here is at -4, 2, so my h is -4, my k is 2, and my radius is 2 in this problem. So all I have to do is plug them in. So once I plug these in, I'm going to go ahead and simplify. A negative with a negative gives me a positive 4 here, and the y minus 2 is just the y minus 2, and then the 2 squared is 4. And I'm done. The standard form of this circle, um, the standard form of the circle with these given characteristics is this: x plus 4 squared plus y minus 2 squared is equal to 4. Okay. Now, again, if I'm going a little too fast, please let me know, slow me down, ask me questions on our last day. Okay. Um, So let's look at this equation or this problem. Write equations of the lines through the given point that are parallel to and perpendicular to the given line. So they're giving us a line here that is in general form, 8x minus 2y is equal to 3, and they want us to come up with parallel lines and perpendicular lines to this given line, but they have to go through this point, 8, 1. All right, so the thing that I need to do in order to get the parallel line and perpendicular line is I need to know the slope of this line, because the slope of the line is going to tell me um, whether a line is perpendicular or parallel. So if the slopes are the same, then that means that we have parallel lines. And I like to say that if we have opposite slopes, then we have perpendicular lines. So let's go ahead and first get the slope of this line that they're asking us to have a parallel and perpendicular to. So here, what I am going to do to find the slope of this line, and the best way for me to see that is to convert this line from general form to its slope-intercept form. And that's just easy by solving this equation for y. Okay, so I'm going to solve for y. And when I do this, I get y is equal to minus 3/2 plus 4x. Okay, so the important thing that is in this equation is the slope. Here, the slope is 4. I don't care about the point that it's crossing here, the b. Okay, all I'm interested in the slope, because again, the slope is going to tell me um, whether a line is parallel or perpendicular. So let's go ahead and start with the parallel line. I'm going to use the point slope formula since they're giving me a point and I have the slope to come up with the equation that is going to be parallel to this line. And the slope on the point slope formula is given by y minus y1 is equal to m times x minus x1, where again m is my slope and x1 and y1 is the point that I want the line to go through. So let's go ahead and substitute our values. So we have here, we have y minus 1 is equal to 4 times x minus 8. And then all I have to do is now distribute the 4. And when I do that, I have y minus 1 is equal to 4x minus 32. And last thing I need to do is just add 1 on both sides, right? So when I add 1 on both sides, I have minus 32 plus 1, which is going to give me a minus 31. So this line is parallel to this given line. And if you see, the slope of my line is 4. And to know that two lines are parallel, they have the same slope and different y-intercepts. And if you recall from the previous slide, we had a different b here, right? That I wasn't interested in. but now this is a line that is parallel to this given line. Now, let's find the perpendicular line that is goes through this point that is perpendicular to this line. So to get my perpendicular slope, what I like to do is I like to get the opposite slope of this one. And the way I think about this is first, I think of this number as a fraction, 4 over 1. And the opposite of this fraction would be its reciprocal. So the reciprocal of 4 over 1 would be 1 over 4. And then this is a positive number, and the opposite of a positive number would be a negative number. So the perpendicular slope for this would be a negative 1 over 4. So this is the slope that is going to be perpendicular to this given line, to this given slope. Okay, so again, I'm going to use my point slope formula again to get that equation. Again, the equation is y minus y1 is equal to m times x minus x1. And I'm going to plug in what I have, the point and my slope. And just like before, I have y minus 1 is equal to minus 1 over 4 times x minus 8. The first thing I need to do is I need to distribute that negative 1/4 to the x into the negative 8. Okay, when I do that and simplify, I'm going to get y minus 1 is equal to minus 1, negative 1 over 4x plus 2. Okay, the last step is to add 1 on both sides. And when I add 1 on both sides, I get y is equal to minus 1/4 x plus 3. And I've done it. This equation is parallel to this given equation that goes to this particular slope. Okay, all right. So let's look at something different. This is two functions here, and what they want me to do is basic operations with these functions. I'm going to add these two functions together. I'm going to subtract these two functions together. I'm going to multiply these two functions together, and lastly, I'm going to divide these two functions together. So here we have the syntax or the notation, how we represent the addition of two functions. We read this as f plus g of x. And basically, to solve these, I like to just do like a substitution method, do what they're actually asking me to do. This is the syntax, but what they're really asking me to do is add function f with function g, the addition of these two functions. And then it just becomes a substitution. F of x is the red, 9x plus 1. The g of x is this blue, x squared minus 4. And I'm going to add these two together. So I can combine like terms if I can, and the only two like terms that I can combine are the plus 1 and the minus 4, the constants. So the order doesn't matter, but we always like to have it in descending order. So the addition of function f with g is x squared plus 9x minus 3. Okay, so the same way for subtraction, the subtraction of two functions, f minus g of x, I like to do it as what they're asking me to do. They just want me to subtract function f of x with function g of x. So again, because there's a subtraction, I'm going to have to do a parentheses for that, for the one in blue, the g of x, right? So we have 9x plus 1 minus this function x squared minus 4. So to drop the parentheses, I'm going to distribute that negative. A negative times an x squared is a negative x squared. A negative times a negative 4 is going to give me a positive 4. Now I can combine my like terms, and again, just as before, I only have two like terms, my constants, the plus 1 and the plus 4. When I add together, it gives me the plus 5. So my solution is minus x squared plus 9x plus 5. Okay. And the next one is the product of two functions, or multiplying two functions together. So again, what they really want me to do, the syntax is fg of x, but this means the multiplication of f of x times g of x. And we know that if we have two variables next to each other, we don't have to put a multiplication symbol. We know that because they're together, that means multiplication. So again, my red is the f of x, which is 9x plus 1. My blue is the g of x, which is the x squared minus 4. And to do this product, I just have to do FOIL, right? I have to distribute the 9x to the x squared to the minus 4. That gives me 9x cubed minus 36x. And then I have to distribute the 1 to the x squared and the minus 4, which gives me the positive x squared and the negative 4. Then I just combine like terms if I can, and I see that I don't have any like terms. So my answer, I could just leave it like that. The computer would accept it. But again, we like to keep things normal, right? So we like to have it in descending order. So this is 9x cubed plus x squared minus 3x minus 4. But again, this is not necessary, okay? All right, and then the last one, we want to divide function f with function g. Again, the notation here is f divided by g of x. But what they really want me to do is just this. They want me to divide function f with function g. So I just do the replacement. F of x is 9x plus 1 is my numerator, divided by g of x, which is my denominator, the x squared minus 4, the number on the bottom. And if I could factor these out in some way or simplify it, I would. But I can't simplify or cancel anything out from this. So my answer would be just this, 9x plus 1 over x squared minus 4. But again, in your final exam, if you have it on paper or on computer, again, your instructor might always ask you to find the domain of this fraction. And the reason why we ask you to give us a domain on this one is because we have a fraction and we never want a 0 for our denominator. So to find the domain of f of g, f divided by g of x, we would set the denominator equal to 0. And if we have a value for it, then now it's going to be our restriction or our domain, right? So here, our denominator is x squared minus 4. We don't want this to be 0, so let's see if it gives a 0. So we set it equal to 0, and we see that we can. I like to factor this. If I factor this, this is a difference of squares. This is x minus 2 times x plus 2. But again, we have two values, right? We have the plus or minus 2. Again, here the example that we did was we used the square root property. We added 4 on both sides, take the square root of both sides. So the square root of 4 gives me this plus or minus 2. So again, the domain for this function here is all real numbers except for 2 and negative 2. And again, we always want that answer in interval notation. So the interval notation would be from negative infinity to negative 2, which is our first value that we cannot use. And then we have this symbol called the union or and from negative 2 to 2. And then the union or and from 2 to infinity. So this is the syntax notation or the interval notation for the domain for this particular function. Okay. All right. So let's look at this. It says, does the function have an inverse? Oh, so let's first review really quick if what they're giving us is a function. So if you recall, in order for us to determine if an equation or a graph is a function, we can do what's called our vertical line test, right? Our vertical line test is checking that every x value has only one y value. So if it passes this vertical line test, then our graph is a function. So again, in this particular problem, I know it's a function, it's a line, but they're asking us for the inverse. And the reason why I'm reviewing, again, just a function is to find if a graph has an inverse function, well, we just do the opposite of that original test for the function. So we had a vertical line test to find if it's a function. So to find its inverse or the opposite, we're going to perform what's called a horizontal line test. So if we do an imaginary horizontal line, and if our horizontal line crosses our graph only once, then the answer would be yes, it has an inverse. So here, again, we are going to do a horizontal line test. And again, you can see it visually here with this imaginary, this line shouldn't be here, but let's say that it's imaginary, this imaginary red line. And if we traverse it through our whole graph, it's only going to cross our graph only once. So then the answer would be yes, it has a function. So let me give you a little advice. Almost all lines have an inverse, okay? The only one that's not going to have an inverse is if you have just a horizontal line, yes? All right, so let me just connect here. Okay, let's go to the next question. So here, determine whether the function has an inverse function. So we have f of x is equal to the square root of x minus a. And they're telling us that x has to be greater than or equal to a. And the reason why they're telling us that is because if we have something smaller than 8, we're going to have imaginary numbers, right? So we don't want to deal with imaginary numbers yet. So let's see if this has an inverse. So one way that we can find if it's an inverse if we graph it, right, and we do our vertical and horizontal line test, right? So what we can do is to find the inverse, what we can do is we can replace f of x with the y, and then what we'll do is we're going to interchange the two values. We're going to interchange the x with the y, and then we're going to solve for y again. And by doing that, we're going to discover its inverse. Okay, so here I had my f of x, and we know that f of x is the symbol that we used that we replaced y with, but we put that y back, and then we're going to swap the variables. So my y's will become x, and my x will become y. And then all I have to do is now solve for y. So to solve for y, the first thing that I need to do is I need to take the square of both sides. And when I take the square of both sides again, the square root of a square becomes an exponent of 1, giving me just y minus a, but you all like to say that they cancel or eliminate each other out, which is okay. Okay, the x squared. So this gives us x squared is equal to y minus 8. So the last thing that I need to do to solve for y is add 8 on both sides. And I'm not done yet, okay? So be careful. To indicate that this y equals x squared plus 8 is an inverse function, we have to use this notation. This f to the exponent of negative 1 x is a representation or telling us that this x squared plus 8 is an inverse function. Okay, so this is a way to solve or to find the inverse of a function. So just to recap really quick again, to find the inverse, replace the f of x with y, interchange the variables, replace the x's with y's, the y's with x's, and then solve for y. Once you've done that, replace back the y with this notation, f to the negative 1 exponent, and you have your solution. Okay. All right, Ms. Chuka, would you like to take over?
Yes, thank you, Mr. Carizales.
Of course.
Okay, so let's continue. Oh, I'm sorry. This was the last one you did, right?
Yes, ma'am.
Okay, so now we're gonna switch a little bit, go into some chapter 2 topics and graphing. And so one of the first question here is for us to sketch the graph, and then we're gonna apply the leading coefficient test, find the real zeros, and then we're gonna graph it. So the coefficient test, in order for us to look at that, we're going to be looking at the leading coefficient, which is the number in front of your x squared term, or the term with the highest degree. And then one of the things that you can do is consider these 4 graphs that we should already know how to graph. And so what you want to look at is the degree and the leading coefficient. So if the degree is even, then your graph is going to behave like this parabola. It's either going to rise to the left and rise to the right, or it's going to fall to the left and fall to the right. If it has a negative coefficient, then that's when it falls right and falls left. If it has an odd exponent, then the behavior is going to be similar to this cubic function. And so if we look at our problem here, we have x squared, so that means that our behavior is going to be like one of the first 2 graphs. Then we have a negative in front of the x squared, so that means that our behavior for our graph is going to be like this one that I circled. And so we can say that the graph is going to fall to the right and fall to the left. Okay, so that would be the last option. So now let's go to the second part, find the real zeros. So to find the zeros, this is quadratic. So we can set it equal to 0. And then we can try to factor. If you're not able to factor, then you can use the quadratic formula. In this example, we can factor. And so one of the first things I did is sometimes having a negative in front of the x squared is not as friendly. And so if you want to get rid of this negative, you can get rid of it if you multiply both sides by a negative. So negative times 0 is 0. Negative times negative would be positive. Positive times negative would be negative. And then negative times negative would be positive. And so now it's a little bit more friendly. So here we have 32 can be found by multiplying 8 times 4. And we need the 12 to be negative. So we're going to have negative 8 and negative 4 together to give us negative 12. So once we have our two factors, we set each factor equal to 0. So our first answer is x equals 8, and our second 0 is x equals 4. So now we have the behavior, we have the zeros. The next thing we can do is find the y-intercept. To find the y-intercept, we let x equal 0. And so if x is 0, we end up with negative 32. And since this is quadratic, we can also go ahead and find the vertex. So we can use the vertex formula here. So x is equal to negative b divided by 2a. B is always the number in front of x, so that's going to be 12. And then a is always the number in front of the, there's a leading coefficient, in this case, negative 1. So we end up with negative 12 divided by negative 2 is 6. To find the y value, we plug in this number back into the equation. So we're going to have negative 6 squared plus 12 times 6 minus 32. And so we end up with a vertex of 6, 4. And now we can take all that information and plot the numbers so that we can get our graph. So here's our zeros, our vertex, and then our y-intercept is going to be way down here. And so this would be the graph for this function. Okay, so now for this next one, we have find the rational zeros of the polynomial function. And so here there's two ways you could try to solve it. One, you can try to factor by grouping. If you're not sure how to do that, then we can use a rational zero test. And so here, to use the rational zero test, we can take the factors of the constant term. In this case, our constant is 9. So those factors are 1, 3, and 9. And then the leading coefficient, we can also take the factors of 1, which is just going to be 1. And so the possible rational zeros are found by dividing the constant term factors by the leading coefficient factors. So I'm going to have 1, 3, and 9. So 1 divided by 1 is 1, 3 divided by 1 is 3, and 9 divided by 1 is 9. So we can look at this list that we just found, and we can test these possible zeros. So the question said to find the rational zeros. It didn't want us to find the possible zeros. So there are some questions that say find the possible zeros. If it says that, then this would be, but since it says to find them, now we go to the next step, which is we can use synthetic division, and you can pick any of these possible zeros. I always like to start with 1. So I'm going to start with 1 and apply synthetic division. So I bring down the 1. 1 times 1 is 1. Add it to this one, we get 2. 2 times 1 is going to be 2. Plus negative 9 is negative 7. Times 1 is negative 7. And we end up with negative 16. Since your remainder is not 0, that means that 1 is not going to be a 0. So we need to try something else. So let's try negative 1. So we apply synthetic division, bring down the 1, and we multiply it out. And so we can see here that we are going to end up with 0. So now that we have 0, that means that negative 1 is a 0. And since that's a 0, we can use the quotient. Since our polynomial was x cubed, we're going to start with 1 less. So this one would represent x squared. And let me go to the next one. So this would be x squared minus 9. And now we can use our quotient to find the rest of the zeros. So notice it's quadratic. We set it equal to 0. I'm going to add 9 on both sides and take the square root. So now we get x is equal to plus or minus the square root of 9, which is going to be 3. So my zeros are 3, negative 3, and I should have 3 of them. So the third zero is going to be -1. So here it says to graph it. The original problem doesn't tell you to graph it, but we're going to go ahead and graph it for practice. And so to graph this, we need to plot our zeros. So here are my 3 zeros. We have -1, -3, and +3. We're going to apply the end behaviors. So this is x cubed, so that means that the graph is going to rise to the right and it's going to fall to the left. Since my zeros were not repeated an even number of times, that means that the graph is going to cross the zeros. And so now we can find extra points. So if we find points between the zeros, that would be helpful. So I'm going to use -2. So if we input -2 cubed plus -2 squared minus 9 times -2 minus 9, then we get a 5. And if we do a +2 on this side, then we end up with -6. And then I also tried 1 that gave me a -16. So if I plot those, here's -1 is down here, and our graph would look something like this. Okay. All right, so now we can go to the next example. Use the given zero to find all the zeros. So here they tell you that 4 plus 2i is a 0. So I can use synthetic division. I'm going to bring down the 1. 1 times 4 plus 2i is going to be 4 plus 2i. If I add it to -12, then I get -8 plus 2i. Now I need to multiply 4 plus 2i times -8 plus 2i. And so that becomes 4 times -8, -32. 4 times 2i is 8i. 2i times -8 is -16i. And 2i times 2i is 4i squared. Let's simplify a little bit. So I squared here is -1. And so let me go back really quick. So -1 times 4 is -4, plus a -32 is going to give us a -36. And 8i minus 16i is going to give us a -8i. Okay, so let's simplify more. And so we end up with -36 minus 8i. Now I'm going to add the 52. So 52 minus 36 is 16 minus 8i. And now we do the same thing. We're going to multiply 16 minus 8i times 4 plus 2i. So 4 times 16, 64. 4 times -8 is -32i. 2i times 16 is 32i. And 2i times -8i is going to be -16i squared. But notice here that the i's are going to cancel. So that -32i plus 32i is 0. And then -1 times -16 is going to be +16 plus 64. That's going to give us the 80. Okay, so now this is 0. And we know that we should have gotten 0 here because they told us from the beginning that it was a 0. Okay, so now that we did get a 0, we confirmed that it's a 0. But the more important thing is we can use what's left over here. We can use to get a quotient. So our quotient is going to be 1 less power. So since this was x cubed, we're going to have x squared minus 8 plus 2ix. And then we have our 16 minus 8i. So now what we can do is, since 4 plus 2i is a 0, that also means that 4 minus 2i, which is its conjugate, is also going to be a 0. So my quotient, my coefficient for x squared is 1. Then my coefficient for x is -8 plus 2i. Then I have 16 minus 8i. So I start synthetic division again. And 4 minus 2i times 1 is right here. -8 plus 4 is -4. My imaginary numbers will cancel here. And then -4 times 4 minus 2i is -16 plus 8i. So this is going to be canceled. So we get 0. So the only thing we have left is our quotient now is going to be x minus 4. And we can set that equal to 0. So x is equal to 4. So my zeros are going to be x is equal to 4, this should be a 4 right here. And then we have our two complex solutions. Okay, so this number here, let me just rewrite it. This should be a 4. Okay, and so that's how we would find the rest of the zeros. So let's go on. Consider the following. So we have a rational function, f of x is equal to 1 divided by x plus 3. And we want to find the domain. So if you notice here, the domain has a fraction. So the domain is going to be all real numbers, except for the ones that would make your denominator a 0. So here, x plus 3, we can set it equal to 0 so that we can find out which number we can exclude. So we have x plus 3 is equal to 0, subtract 3, and we get x equals negative 3. So your domain is going to be all real numbers except for negative, because if you plug in negative 3 here, you're going to end up with 0 down here. Okay, so our domain is all real numbers except negative 3. Okay, so that would be their last option here. Now let's go to letter B. Identify the intercepts. So the x-intercept, we're going to let y equal to 0. So let's let y equal 0. And I need to solve for x. So I'm going to multiply both sides by x plus 3. But when I do that, notice what happens. We get x plus 3 times 0 is 0. And then on this side, the x plus 3 will cancel. So we end up with 0 is equal to 1, which is a false statement. So we say that the x-intercept does not exist. Now let's try the y-intercept. So the y-intercept, we let x equal 0. So if x is 0, we're going to end up with 1/3. And so the y-intercept is 0 and 1/3. Then to graph, we're going to need to know the vertical and horizontal asymptotes. And so here we're going to have, just as a review, the vertical asymptote is a vertical line, and we represent it with a dotted line. And so in order to find the vertical asymptote, we're going to factor the numerator and denominator, and then we're going to set the denominator equal to 0. If you cancel any like factors in step 1, then it creates a hole in the graph. Okay, so here, these are already factored, so we don't have to do anything. We can just set the denominator equal to 0. So x equals negative 3 is our vertical asymptote. And then if I was to graph it, it would look like this as a dotted line. And now the horizontal asymptote. So as a review, this is a horizontal line that is dotted. And there's 3 situations. The first one, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is at y equals 0. If the degrees are the same, then we're going to divide the leading coefficients. If the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. However, if the degree of the numerator is 1 more than the degree of the denominator, then there will be a slant asymptote. So let's see what our situation is. The degree of the numerator here is 0. The degree of the denominator is 1. So the degree of the numerator is less than the degree of the denominator. And so that's going to tell us that there exists a horizontal asymptote at y equals 0. Okay, so if I had to graph it, it's going to look like the blue dotted line that is horizontal. And so now we can take all the information we have and graph everything graph the function. So these are all the things that we discovered as we were solving this problem. So here's my vertical asymptote. And then I'm going to plot my y-intercept is at 0, 1/3. And I need to know I need to know more information. So we can plot some points on the left side of the on the right side of the vertical asymptote. So if I have -2 and I plug it in, then we get 1. And if I have a +2 and plug it in, we're going to get a 1/5. And so that's going to look like this. So that's going to tell us what happens on the right side of the line. But what about the left side of the vertical asymptote? So on this side, I can pick -4, and I get -1, and -5 gives me -0.5. So if I plot those points, then they look like this. So if I connect them, then my graph would look like this. Okay. So the graph is going to approach that vertical asymptote, and then of course it's approaching the horizontal asymptote, which we didn't draw it with the dotted line because it is the y-axis. So we don't have to put the dotted line for the horizontal asymptote. And WebAssign, well, they give you choices, so then you can just see which one matches your graph. Okay. So now for chapter 3 problems. So here it says use properties to expand the expression. So expand means that you're going to end up with more than one log. So here this log has division. So we can apply the quotient rule, which tells us that we can separate the log with subtraction. So we're going to have log 5 square root of x squared minus 9 minus log 5 of 4. Now, when we're doing these logarithms, if you see a square root, we can, so the square root is going to be x squared minus 9 raised to the power of a half. And then we can take the exponent to the front. So we end up with 1/2 log 5 of x squared minus 9 minus log 5 of 4. So that would be your answer, your final answer. Well, we can factor x squared minus 9. So let's go ahead and do that. So x squared minus 9 is x minus 3x plus 3. And these are being multiplied, so we can separate using the product rule, which means we can separate them with addition. Now the half belongs to both of these, so we're going to distribute it over. So we end up with 1/2 log 5 of x minus 3 plus 1/2 log 5 of x plus 3. Okay. Condense means that we want to rewrite this so that there's only one log. Since there's no parentheses, I'm going to start from the left side. But before we do that, if there's any numbers in front of the logs, you want to write them as exponents first. So this 6 can be written as an exponent, and 7 can be written as an exponent. So now we have log y to the 6 plus log z to the 7th. And now I have log x minus log y to the 6. Since they're being subtracted, I can write them as division using the quotient rule. So now I have log of x divided by y to the 6. And now these are being added, so we're going to combine them together using the product rule, which means to multiply. Since we have addition, now we multiply. So we have x y to the 6 times z to the 7th. We can simplify, and we end up with x times z to the 7th divided by y to the 6. Now for letter B, there is brackets involved. So you want to do what's in the brackets first. So here we have natural log of, let me see which one. Oh, let me go back. Okay. So let me go back one more. So I don't have it in there, so let me just work it out really quick on this page. So let me get my pen. So you want to work with this first. So since they're being added, then we're going to have natural log of x minus natural log of x plus 1 times x minus 1. Okay, now these are being divided, so we can write them as division. Okay, and then if you like, you can multiply it out. So we have, this will be x squared minus 1. So that would be your answer there. Okay. Now on the next page, they want us to solve for x. So in order to solve for x, we're going to use some of these properties. And so for the first one, we have natural log of x minus natural log of x plus 6. So we can combine these two logs to make it into one. And so if I apply the quotient rule, then we end up with natural log of x divided by x plus 6 is equal to 7. In order to help me solve for x, I'm going to change this to exponential form. So natural log is the same as saying log of base e of x divided by x plus 6. And so to convert this to exponential, we take the base, which is e, and the log is equal to the exponent. So in this case, the log is equal to 7. So that makes 7 the exponent. And then we have the rest of the stuff here. So I'm going to multiply by x plus 6 on both sides to start simplifying. And so in order to solve for x, I'm going to have to multiply by e to the 7th times x and e to the 7th times 6. So we end up with e to the 7th x plus e to the 7th times 6 is equal to x. So next we can try to put all the x's together. And so I'm going to go ahead and subtract x on this side, and I'm going to subtract e to the 7th times 6 to the right side. So now these terms on the left side have an x in common, so we can factor out an x. And if I factor out an x, I'm left with e to the 7th minus 1. I'm trying to solve for x, so I can divide by e to the 7 minus 1. And I end up with x equals negative e to the 7 times 6 divided by e to the 7th minus 1. And if I use a calculator, that's going to be negative 6.005. And so here I just showed you the steps that I did in my calculator to get that answer. Okay, let's look at letter B. So letter B, oh, and always check your solution, right? So if x is negative 6 and we plug it in for x here, then we cannot take the logarithm of a negative number. And so since we're going to have natural log of a negative number, then that's not going to be a solution. So x equals negative 6.005 is actually not a solution. Okay, so let's go on over here. So now here we have a natural log of x plus 9. And then I have two natural logs here, which I can combine as one using the quotient rule. So I get natural log of x minus 6 divided by x plus 6. And we're dividing since they're being subtracted. But now notice that this natural log and this natural log, they both have the same base. So we can use the one-to-one property. And we can set x plus 9 is equal to x minus 6 divided by x plus 6. In order to solve for x, we can multiply both sides by x plus 6. So we get x plus 9 times x plus 6 is equal to x minus 6. Since the x plus 6 will become 1 here, or they cancel. Now let's continue to simplify. So if we multiply this out, we get x squared plus 6x plus 9x plus 54. And then on the right side, we have x minus 6. So this is quadratic, so I'm going to have to put everything on the same side. So let's go ahead and do that. If I subtract x and I add 6, then combine like terms. So we're going to end up with x squared plus 14x plus 60 is equal to 0. So now we can try to factor, or we can use a quadratic formula. So if we use the quadratic formula, we end up with a negative inside of the square root, and so this solution is not going to be a real solution. So we really should put no real solution, because there is a solution, but it's going to be in the complex number system. Okay, we have one more. So log 9 of x minus log 9 of x minus 8. We can combine those again with division. So we have x divided by x minus 8. I can change to exponential. So 9 is my base. The log is equal to a half, so half is going to be my power. And now I can multiply both sides by x minus 8. So 9 raised to the half power is the same as the square root of 9, which is going to be plus or minus 3, multiplied by x minus 8 on both sides. So I'm going to separate it, one for the positive and one for the negative. And so if we multiply x minus 8 on both sides, we get 3 times x minus 8 is equal to x. 3 times x is 3x. 3 times negative 8 is negative 24. Subtract the x, so we get 2x. Move the 24 to the right side. So a possible answer is x equals 12. And on the other one, we have multiplied by x minus 8 again. And so we end up with x equals 6. So now you want to check your solutions, right? If I have a 12 here and I plug it in for x, then that's positive, that's okay. And 12 minus 8 is 4, and that's okay. But for 6, if I plug in 6 here, that's okay. But here, 6 minus 8 is going to give me a negative 2, and then that's not going to work out. So the only solution here is x equals 12. Okay, and so I have it worked out here. So we cannot have a log of a negative number. That's why we're gonna exclude that from our solution. And so basically, those are a little bit of everything. The only stuff that is missing from this review would be the chapter 7 and chapter 8. But we have been covering that the last 2 weeks. And so if you want to download this presentation, you can, or this PowerPoint, right here where my mouse is, you should see a box with an arrow. Just click on that and it'll let you save the PowerPoint. The other thing is, if you want to go back to see any of these examples, they have been posting the video links, so you can always go back and look at that. And so I just want to wish everybody a great week next week for your finals. And if you have any questions, we are here to help you. And thank you for joining us throughout the semester.
Thank you, Ms. Chuka, and thank you also to Mr. Ruben Carizales for the wonderful presentation that you gave us today. We do want to remind you that, again, this is the last presentation for the spring semester. We will be back in the summer semester, so just make sure to keep an eye out for the flyers through the EPCC campus mail or Facebook or Instagram. Like Ms. Chuka said, we want to remind you that the previously recorded sessions are available on YouTube on the Tejano Virtual Events playlist. This session will also be available on the playlist later today. Also linked is a short survey to help us improve the Tejano virtual event sessions. Please do take a few moments to fill it out, and that would be most grateful. We want to thank you all, and we want to also let you know that at 1 o'clock, we will be having the children's program at Northwest and Children's College. Thank you for coming in today, and we do hope that you have a lovely weekend. If you have any questions, feel free to use the chat box or your mic. We hope to see you again very soon for the Happy Math Hour.